Just want to say, to start off, thanks a lot to InThought for inviting me to come out here. And, it's a big honor for me to be a keynote. I've been to many SciPy conferences and presented many times, but, it was a big honor when I got an invitation from Prabhu and Warren to give a keynote here. And to the other sponsors as well, Microsoft and Google. I'm going to break my talk up into a few parts here today. Part of what I want to do is talk about the history of matplotlib and where we came from and why we did what we did, and where, moving up to where we are today. In the process of almost 10 years now of development of open source software, I've learned a lot of things. I have, taken on a lot of dogmatic views, and as I've gotten older, I've realized a lot of those dogmatic views aren't correct anymore. So I've learned some lessons, and I've learned some areas where those lessons aren't really true anymore. I want to kind of share some of those views with you that I've developed over time. One of the things I want to focus on is how to stay flexible as an open source software project. The pace of technological change in the commercial world, in the open source software world, is really staggering. If you look at how fast leading technologies come and go. We've been around now for about 8 years, which is, it's an eternity in the software world. So how can we continue to develop and stay relevant to the new class of tools that are coming out? So I want to talk a little bit about how you stay flexible and how you stay young at heart as a software project. That'll sort of conclude the PowerPoint part of the talk, and then I want to move into more of an interactive demo, showing you some of the new stuff we've been working on in the latest release of matplotlib, as well as the new stuff that's coming down the pike in our upcoming release in a couple months. A lot of good work from a lot of really amazing developers. And then the last thing I want to touch on is what I think are the big challenges we face going forward as a graphics library. And this kind of touches back on the idea of being flexible and staying young. There's a lot of sea change in the technology of graphics that's happening right now. And there's some particular challenges for matplotlib and how we can stay relevant in that world. So that's kind of the overview of what I want to talk about today. My title is Lessons from Middle Age. And so I told my mom and a couple of my friends about my title, and they're like, well, middle age, what do you mean? Is that your project or is that you? And I was like, well, it's kind of both. There's some parallels between the age of a software project and the age of a person. When I started this thing, I only had one child and not a lot of dependencies, and I was kind of footloose and fancy-free and could do what I wanted. And now I've got a 14-year-old daughter and 2 other kids and hundreds and thousands of users worldwide. And there's just a lot more people depending on me, and it gives me a lot less flexibility to do what I want to do. And so there's some parallels there between age in a software project and age in a person. But I wanted to talk a little bit about the history of matplotlib. There was a NumPy thread recently where there was a lot of brouhaha and back and forth about NumPy community and development and process, and Travis Oliphant was mixed up in it. And one of the things I did in that thread was I gave a kind of a history of NumPy versus numeric versus numarray, and Travis's role in bringing all those communities together. And one of my matplotlib developers emailed me off list, and he said, wow, I didn't really know there was anything before NumPy. And that was an interesting perspective to me, because NumPy came onto the scene in 2006, which is kind of late in the game for a lot of us. But for people who are grad students and college students who have been using these tools, that's sort of the whole history for them. So I thought it'd be interesting to give a little bit of history. My first SciPy talk was in 2004, which was 8 years ago You know, again, in terms of the lessons from middle age, you know, when you're a little kid and your birthday's 2 months away, you think, oh my God, that's an eternity. But then every time you see your great aunt, you haven't seen her for 2 years, and she says, oh my God, you've gotten so much bigger. And, you know, what's happening there is to old people, 2 years is no time at all. But to a young person, 2 years is most of their life. So there's this great quote that I read that said, no matter how old you are, your first 20 years will be the best half of your life. And I think that captures that notion of the perception of the passage of time. I have a slightly different theory on that, which is the way you perceive time is directly proportionate to your age. So when you're 40, 5 years is 1/8 of your life. And when you're 60, 5 years is 1/12 of your life. And you perceive that as a fraction. So that kind of has implications that the older you get, the faster time progresses. So time has moved very quickly since our first talk, you know, from my perspective, from my first talk at SciPy in 2004. So I'm going to kind of run over the seminal moments in matplotlib development and then move forward into some of the stuff that we've learned from there. We kind of had an ignominious birth in matplotlib. We were born out of rejection from my good friend, Fernando Perez. I was using Python since 2001. Formerly, I was a big Perl, MATLAB, and C++ user. And like a lot of people in those early days, I had a hodgepodge of work processes. I would have Perl scripts that called C++ numerical routines that would dump data files, and I would load them up into MATLAB to plot. After a while, I got tired of the MATLAB dependency because of the site licensing and the other issues that were going on with that. So I started loading them up in GNU to plot. And IPython had this nice little interface to plotting. Like right now they have pylab, which is an interface to matplotlib plotting. Formerly they had this interface to GNU plotting. And I really liked the MATLAB syntax. So I decided to make a patch to IPython to make their plotting look like MATLAB's. It was about a 100-line patch. And it was my first Python patch ever. So I was pretty proud of it. And I got a response back from Fernando, you know, thank you so much, this looks interesting, but I really have to finish my PhD. I've promised myself I'm not going to look at anything IPython related for 6 months. So I can't look at it right now. Well, you know, one of the rules I've learned about software programming is that if something can't be done within 6 months, it's effectively an arbitrary amount of time. So, you know, I couldn't wait an arbitrary amount of time for my patch. So I started coding up my own solution, which was matplotlib. And between 2002 and 2003, where I had my first commit there, I didn't wait a year. I was just basically developing on my own in my own little directory, writing matplotlib, and I eventually committed that to my first CVS repository and did a release in the same year, which was matplotlib 0.1. Actually, in preparation for this talk, I downloaded matplotlib 0.1 just to see what it looked like, kind of like, you know, tour back in the Wayback Machine. And when I untarred the tar file, I was horrified. I had all these like tilde files, which were my Emacs backup files. I had all these PyC files, which were my compiled byte object files. I just essentially had tarred up my working directory with no cleaning and released it. So, you know, that's how we got our start. But I was working very feverishly, mostly alone in the beginning. Andrew Strahl was our first contributor. He developed log scaling. Tony Yu, who's in the audience, was one of our very early developers, but he abandoned this for many years after that. But now he's come back into the fold, so we're happy to have Tony back. But after about 2 years of pretty intensive development, we'd gotten big enough, we'd probably done 5 major releases and 40 point releases and bug releases. We started to develop a pretty decent user base by 2004, and that's when Perry Greenfield brought his team from the Space Telescope Institute on board. These guys manage the image pipeline from the Hubble Space Telescope. They do an awful lot of Python, and they have big, institutional resources behind them. So having those people join the project was very inspiring for me. And that's when I really kind of kicked it into high gear and, started working very hard on the things they needed. I think just because I was very proud to have somebody like those guys working with me, and they contributed resources, and I started, they needed images. They needed image support at the Space Telescope. So I, worked on adding that. We added mathematical text rendering support. So there were a lot of features they needed that we worked together to add. Throughout the years, their support has been invaluable. I'll talk a little bit more about some of the work they've helped us with over time. So we were born out of a patch rejection. We were also born out of a real need to develop some stuff I was working on in an epilepsy lab at the time. We wanted to develop an application for doing seizure analysis, which we'd been working on in MATLAB as well as in some proprietary applications. So this was the first matplotlib application. It was a GTK application. This is a screenshot. This code currently lives in the Neuroimaging in Python directory, which is a brain research project primarily headed out of Berkeley. And I had an application called pBrain, which I think stands for Python Brain, but I liked the pBrain. And so this is a screenshot from that. So matplotlib initially tried to solve a few different problems at once. It wanted to be a user interface toolkit. It wanted to be something where I could do all my scripting in one place, so I could write applications and not have to have Perl, call C++, call MATLAB, but have everything integrated into one. And I wanted it to have kind of a really easy interface for me and other people familiar with MATLAB to use. So in 2004, mere 8 years ago, I gave my first SciPy talk. The room was about this size at the time, I think. So the conference has grown a little bit on the wings. And I remember, there were all my heroes were there. Paul Dubois, who was the lead numeric developer, and Todd Miller, who was the NumArray developer, Fernando Perez, the IPython developer, Eric Jones, the SciPy developer. So all these guys whose tools I've been using for years. So I was a little bit nervous, coming up to present my stuff for the first time. And one of the researchers from the National Centers for Atmospheric Research got up before me, and she was presenting a graphics library that she had just developed called Pingle. And so she gave that talk. And then at the end, Paul Dubois, grand old man of scientific Python, stood up and basically said, "Why are you developing another plotting library? There's no need for this. We already have this in these packages here." So, I was next on deck to present my new plotting library. So this was not a happy moment for me. So I, got up, did my talk. It turns out, though, that Paul Dubois was not my toughest critic. It was Robert Kern. I just presented my LaTeX rendering. I was really proud of this new stuff I'd done. I'd written a LaTeX parser. Donna Knuth has always been a big hero of mine. And I'd written this LaTeX parser and a LaTeX layout engine. So I was showing one of my mathematical equations that I had rendered. And I kind of stood there like the proud father beaming and looked down at Robert Kern in the front right, and he just had this glare on his face. And it's like, you know what? There's too much space between the parentheses and the X. Your kerning isn't correct. So, fortunately, we've made a lot of progress there. Michael Drupal, again, under Perry's tutelage, has implemented all of Donald Knuth's box and glue algorithms. So now we do slightly better layout work there. We initially were supporting NumPy and numeric and NumArray. There was this big schism in the Python community with 3 array libraries that people were working with. We were trying to support all 3. Travis came in and did an amazing job writing NumPy and unifying those communities together. Another big moment for us was when the Jet Propulsion Laboratories came on board and used matplotlib in their, what they call MATLAB for space travel. So sort of in the ground tracking of spacecraft in the Mars mission, that when the rover landed on Mars, they brought in some requests for lots of new features, like better support for ellipses. We were doing a polygon approximation. They needed something better. Date time, other kinds of plot types. they brought some additional institutional support on board. And this was, for me, one of our finest moments when we at least participated in some small way in this really seminal achievement and landing on Mars. My kids and I were in the bedroom cheering when the thing actually, so, I kept telling them, look for my graphics on CNN. And they had all these really awesome 3D pictures of the rover, the orbiter landing, and you're like, is that yours, Daddy? Is that yours? No, that's not mine. Michael Drupum has been one of our superhero coders in matplotlib. He's done, it's a big project, and it's a complex project with lots of C++, lots of Python. And he's been one of the guys who would come in and put the entire thing in his head and help us refactor it and simplify it and make a cleaner code base. So as I've, transitioned from academia, meaning lots of time for open source software development, to industry, meaning a lot less time for open software development, he and a lot of our other developers have really stepped in and filled the void. So it's become a very well-developed project, going from a bus factor of 1 when I started to probably a bus factor of 10 now. So, we're in pretty good shape in terms of our development. We've made, I think we were the first scientific project to make the transition to Sphinx. One of our developers emailed me and said, your logo kind of looks like it's from the 70s, which is this little thing down at the bottom. That was the original matplotlib logo that I developed. And I don't know where I came up with the mustard yellow and red theme, but he's right, that needed a little bit of improvement. The transition to GitHub has been very transformational for us. Initially, for me, it was another version control system, but it's really transformed our development, and I'll talk a little bit more about that later. We went from poor man's regression testing, where I ran a script and it put 40 plots on the screen and I looked at them, to proper unit testing. We have unit testing in image libraries is a little tricky because we have to do unit testing of images. So we have a baseline set of about 300 images in our repository that we run tests against every backend, and then do automated image comparison with error thresholds so that we can make sure that our output stays clean. And hopefully I'll get a chance to show you some of the GitHub tools we use in our image regression testing suite. We added 3D support in 2009, which has come a very long way. I used to tell people it was mostly a toy, and now I think it's kind of a cool, shiny toy. This is just a screenshot of our GitHub image differencing here. So whenever we fail a unit test, we can push, since all of our images are stored in GitHub, our baseline images, we can push the image failure up to GitHub and use their really cool image tracking tool. So this is an image diff, actually, which shows you image A minus image B. So I can see which pixels had changed before and after. And then we can decide, is this a material change, or is this a free type version 2.18 on OS X version 10.x issue? So this wraps up sort of our milestones. We have finished the transition to Python 3. That's a big development recently. We've been working on this for almost 2 years. Initial stages in 2010. There's kind of a chicken and egg problem. We had to wait for NumPy to finish its transition to Python 3 before we could begin in earnest, because we depend on them so heavily. And now we have complete support for Python 3 that'll be coming out in our next library. So we've achieved a measure of success in the open source world, and I think it's kind of worth reflecting back. What was it that enabled us to get to where we are today? When we started, there were probably 30 plotting libraries in Python, much in the way that 2 years ago there were 20 machine learning libraries in Python. There's clearly a huge need, and clearly a lot of people trying to solve that need. I think some of the ingredients for our success were, I had this initial fanaticism, and I was a student, and I had time to work on this thing 60 hours a week, for years in a row. We see people doing that today still. I think Wes McKinney of Pandas fame is, putting in the 80-hour weeks to make Pandas this amazing tool that everybody can rely on. Every once in a while, people just get bitten by the open source bug, and I don't really know why I was so bitten. It was something about the altruism, something about participating in the community, something about having people use your stuff, that whole mix of things that drives people to open source. So part of it in the early days was me just spending a lot of time. I think some of the other ingredients were we really tried to be everything to everybody with one caveat. We didn't try to be a 3D library. But everything else, if it was in the 2D space, we wanted to support it. And one of the important things there was we were going to support GTK, Qt, TK, OSX, because it turns out the way people choose plotting libraries is, hey, not who has the coolest plots, it's my lab needs a TK plotting engine, who can plot in TK? So we wanted to at least meet that first threshold that we can do it in your toolkit, on your platform, and then give you all the plot types you want. And I don't think we really ever tried to be the best in the beginning at everything. We just wanted to be there and be okay at it because we can fill in the gaps later, and over time, many of our things I think have become the best at what they do, or at least competitive with the best. But initially, we wanted to be there. And another reason that I think we were successful was I heavily trolled for users. And that means I was out there on mailing lists when people on the Python list were asking, how do I make this plot type? I would say, well, you can do it in matplotlib, and I'd give them an answer. And when I would post on my announcement list, I always made sure in my subject header I had certain keywords that Google would pick up, like Python plotting package or Python graphics package. So I was doing really poor man's search engine optimization, trying to make sure people would find us. I think one of the big things that contributed to our success was this MATLAB interface that a lot of Python users kind of bristle at, but it gave people a really simple, familiar, stable API that they could come at. And then over time, the network effect kicks in, and our users became developers, and that's what really contributes in the end. So I'll kind of cruise through some of these lessons that we've learned. I've talked about the familiar API, that on the left-hand side you have your MATLAB code, and on the right-hand side you have very early Python code from matplotlib, and you can see there's a lot of familiarity there. So people can come in with an API that they know, and that doesn't change at all over time. One of my lessons that I've learned is, don't be afraid to break out and do something new. When people start to do something new, you get a lot of pushback from people. So I'm sure when Wes started Pandas, he heard from people saying, hey, you shouldn't be developing your own data array object. That should go into NumPy. You shouldn't be putting your own stats. That should go into stats models. You shouldn't be putting your own plotting into Pandas. That should be going into matplotlib. But sometimes people just want that freedom to just work at their own pace, do their own thing, and develop. And there have been some successful projects where people they go it alone and they do a really good job. And I think that's the great thing about open source software is you have that freedom to go the direction you want to go in. But you have to be prepared to sacrifice a few years of your life to do that. I think there's a much easier and kinder way to succeed, which is, take advantage of this really large community we have now. Go with a distributed development model like we see on GitHub. And I think these projects that I've illustrated here, Scikits Image, Scikits Learn, and SymPy have shown you the power of really harnessing that distributed community. No one person had to sacrifice years of their life to succeed. They've really done a good job harnessing a wide network of developers. One of the things that I think is important is to really embrace new tools. If it's not in the core of your library, in the ancillary tools you use, because when you want new developers to come in, those people want to be using GitHub. They want to be making nice documentation in Sphinx. They want to see you have unit testing. They want to know if you have Travis and Jenkins and continuous integration. So, it's important in the ancillary tools to make sure you stay current, to attract that current crop of new developers. This one's a little bit harder as a lesson, but if you can get a superhero to join your project, it makes a really big difference. I found, for us, that was Michael Drupeboom from the Space Telescope Institute. We've always been very permissive with developers. Anybody who shows promise, we're happy to give, commit rights to, and we've had great success. No one's ever done any harm to us. So, people are here, they want to contribute. I don't think having a lockdown model has served anybody well. This is one of the lessons that I used to believe was true, and now I've seen is not always true. But I used to say, if somebody came to me and said, I'm going to develop this feature, and it's going to be really great, that feature would never come. But then, all of a sudden, features that did come I would never hear from. So like 3D plotting on matplotlib, a huge feature. The guy just dumped it in my lap. Never heard of him before, never knew he was working on it. And so I came to believe that if you said you were going to do something, you would never do it, and the only time you would get something done is if you weren't going to say you did it. I've found that a couple of examples where that's not true anymore, so I've had to back off on that. But I think we get a lot of psychological comfort from, thinking about the things we're going to do. You don't want that comfort to distract you from the angst of actually getting the work done. The last thing I want to talk about before I jump into my demo is, how do you stay young as a software project? And I've got a couple quotes up in here from the Research and Motion guys. And, in 2007, they were the leading smartphone company. And now they're struggling to stay alive. These are all fun quotes, but I'll just read one of them. The most exciting mobile trend is full QWERTY keyboards. I'm sorry, it really is. I'm not making this up. That was in 2008. So, a little stock chart of Research and Motion versus Apple. It's just a kind of a cautionary tale. In 5 years, you can go from the industry leader to nowhere. So how do we avoid that ourselves? How do we, not become set in our ways? So I decided to take a quick look over a couple of the other projects in the scientific Python world who were, making great strides, and to see what was going on with them. So I saw this tweet from Wes McKinney. It's like, Olo has gotten quite the makeover, and pointed me to the Pandas Olo page. So I went over to look at what's going on there, and it said, Pandas, it's 15 years of effort to build. So they have these code metrics. It looked at lines of code, and they have this kind of weird metric. And so, Pandas, and I thought, 15 years, to be 15 years old again, footloose and fancy-free, no responsibilities, can act crazy, jump out of fast-moving cars. So I had this real kind of envy of Pandas there. So I wanted to look at a couple of the other projects. NumPy, 60 years of effort to build. And there's, my view of NumPy is Titan there. It's got the world on its shoulders. Everyone in the scientific Python stack depends on them. And 60 years of effort entrenched in their code base. So, losing a little flexibility there. And poor SciPy. 179 years old, deep into the Python stack. And, one of the things we've seen is the flourishing of the sidekits. I think one of those reasons is because it becomes very hard when you're as big and as important as SciPy is to move fast. You have to move slowly at that stage. IPython is this great conundrum, They've been around for 11 years, and yet they've had this rebirth. So I've got this picture of the Fountain of Youth here. Part of it is, even though they've been around for 12 years, they're only 19 years young in code space. So that gives them a little bit more flexibility. And matplotlib, 97 years old. I was thinking I was middle-aged, but now I'm worrying a little bit more. We're a pretty big project. These numbers are a little bit fake because they depend on other code you've brought into your project, so you have to take them with a grain of salt. But I made a little chart here, and I think there's a lot of things that go into flexibility. Obviously, the spirit of the founders and the development and the community, that's all really important in terms of being flexible. What I'm pointing out here is there's some structural things that are going on as well. How old are you in real years? It's sort of a proxy of how many real users you have. And that limits your flexibility, because new users are different from old users. New users can change when you change, because they only wrote that code 6 months ago. Somebody who's an old user, they may have written some code 6 years ago. They're not ready to change. They forgot what they wrote 6 years ago. Then there's code years. How hard is it to move that big stack? I think one of the most important factors, though, is where are you in the stack? NumPy's the core, right? They've got the world on their shoulder. Matplotlib, we're an application. We're pretty high up. We make plots. That gives us some flexibility. And IPython is about as high level in the stack as you can get. Even though they're a library, 99% of the people use them as an application. And that gives them a lot of flexibility. So, we've seen some angst and hand-wringing on the NumPy and SciPy mailing list. Why can't we be flexible in, developing, and why is energy going to scikits instead of SciPy? And, I just want to point out, I think a lot of that is structural, more than it is the community, and more than it is the kind of the willingness of the developers to stay flexible. Those tools are really deep at the core of what we do in Python, and the world depends on them. So I'm going to transition here into my notebook. I haven't gotten this uploaded, but I'll be happy to share it with you if you're interested. So I'm using here the shiny new IPython notebook from Gitmaster. And I just want to show you a few of the things we've been working on in the current release of matplotlib, as well as the stuff we're working towards in the next release. This is an Irish captain named Sankey. He developed these charts called Sankey diagrams, which basically are a way of mapping energy flows. So this is one of his diagrams of the steam engine. And what you see here is the width of these lines basically show you the amount of energy at every stage in the process. So on the left side, you see some energy in the boiler that flows into the steam pipe. You see how on the very left side, some energy flows out as wasted heat. So it goes to the steam pipe. And then on the upper right, some energy flows out of the boiler. That's the actual work that gets created. If you can see my mouse, that's the amount of work, the width of that. So this is kind of the energy loss that happens, and it flows back to the condenser. So that was the original Sankey diagram. One of the most famous Sankey diagrams, if you're familiar with Tufte, is this chart by Menard, which shows you Napoleon's march to Moscow and then the ignominious retreat back. And the beige line shows you the army as they are on the attack. The width of the line shows you how many soldiers there are. So here's some soldiers split off from the main line. The black line shows you the army in retreat. And as you can see, there's not that many people coming back here from Moscow. And the two armies join up here, so the line gets a little bit thicker in retreat. But then they try to cross this river. It's a freezing cold river. It's a very famous battle. Not that many people, it's very visual. This is how many people make it back to Paris. So this is a really famous information graphic in a Sankey diagram. So we added support for these in our last matplotlib release. And this is the basic Sankey diagram, which shows you how energy flows in and energy flows out. So for example, this 15 here, I'll just give you a quick example. If I say there's 45% of energy flowing in there, then now that gets updated to 45, so it gives you a different kind of flow. And they're pretty easy to configure. Like if I want that 45 to come in from the bottom instead of the top, I just make that -1. And now my 45 comes in from the bottom. So you can create these information flow diagrams. This is a single node of a Sankey diagram. So earlier I showed you there was a boiler connected to a steam engine connected to a condenser. Each one of those you could consider a node. This is a single node because each node could have energy inflows and outflows. But you want to connect the outflow of one node into the inflow of another node. You can create much more elaborate looking Sankey diagram. So this, for example, is a single node in a Sankey diagram, which is connecting to others. So this is showing you the thermal efficiency of a turbine, a modern turbine. It's a 2-turbine system. And the code in matplotlib to generate it is obviously more complex, but you can do a fair amount there. So this is one of the things we've added, just kind of neat flow diagrams. Another feature we've added recently is something called tight layout. We have always had this philosophy in matplotlib, which was inspired by the Windows operating system, because Windows was always a little too helpful to me, and I didn't like my computer helping me. I just wanted my computer to do what I told it to do. So I never tried to make matplotlib too smart in terms of its layout. And so a lot of times you'll see stuff like this when you make a graphic, like your title overlays your tick labels, because we're basically allowing you to lay it out the way you want. But we've bowed to the pressures of the world and added this feature called tight layout. So you call this once on your figure, And it basically looks at all your elements and says, I'm going to try to lay this thing out a little bit more intelligently for you. So that's a nice feature to help you get graphics that are more quickly readable. Single function call works pretty well. There's been a lot of support added in our 3D plotting library. This is the NumPy logo that Clue Uo has been working on. This is rendered in BTK. So his first rendering was in BTK. And this kind of shows, for me, this looks pretty ugly. Not to disparage BTK's rendering too much, but there's the aliased lines. I know there are things you can do in BTK to improve this, to get rid of aliasing. So this is kind of a first pass. But the subsequent rendering of this thing was using matplotlib's 3D rendering engine. And because we're a 2D rendering engine, we take really seriously stuff like anti-aliasing and things like that. So we're a lot slower, but I think our rendering quality is better. So the 3D rendering has gotten better. This is a longer example of a NumPy animation. I can jump out of my, just see if I can jump into here. Clue animated his thing just by changing the viewport there. It's kind of a fun little example where he's just basically changing the camera position. So you can get reasonably decent interactive speeds using only matplotlib, 2D rendering, no hardware acceleration. Computers are getting faster, basically. So Mplot3 has come a long way. This is a nice little example that was added in our last release. So this is a basic wireframe that we've had for a while. One of the features we added was making our contour plotting 3D aware. So we can now basically tell it, give us the projections onto the planes. So you can see the contours projected onto the planes. So you can see each contour in the X, Y, and Z direction. Just a few lines of code makes for some nice visualizations. This is some new code that was added recently on doing triangle plotting. So a lot of times you just have some X, some Y, and some Z, and I want you to make a 3D plot. So you have to do a triangulation and the graph. So this is a simple example where you have 3 1D arrays, X, Y, and Z, and do you just call plot trisurf. So it's a single plot command on 3 1D arrays, and you get this nice Pringle here. A lot of work has been done in our animations module. So this is stuff that's in the latest release as well as in the upcoming release for basically making movies from matplotlib. This is one that we call an artist animation. And so what we basically do is you start off with a list of frames, and you just iterate over whatever you want to iterate, and you call some matplotlib plotting function that returns what we call matplotlib artist. It could be a line, it could be a rectangle, a circle, text. In this case, it's a p-color diagram, but you add that to your list of frames, and these are the things you want to animate. And then you call this artist animation over the list of frames, and you can configure your writer. We have writers for FFmpeg and mencoder, and there are ways of specifying, if you've worked with these libraries at all, there's a ton of command line arguments that need to be played with. But our animations return a IPython notebook embedded HTML, so you can run your animation in IPython and get a movie embedded directly. And this is something that will be in the next release, but it's not currently in matplotlib. So that's kind of cool. We don't yet have interactive figures in IPython, but we can fairly easily generate animations in matplotlib and embed those as movies in IPython. And I just kind of want to show you how easy that is. So the IPython notebook has something called a display protocol. And all you have to do is define some classes with special methods, and if they're defined, IPython will call them. So what we do in our movie is we just want to return the file name of the movie we just made. So we inherit from strings. So I'm going to create this class called embed.html. I inherit from the string, and I just return this HTML with the file name embedded in it. And so if you're a normal user, like from the standard Python shell or in a script, you just get back this thing that inherits from strings. So it looks like a string to you. But if you're IPython, it sees that I've defined the special method, and it will call that and actually embed that HTML directly in the notebook. And that's how we can do tricks like call save and get a nice embeddable widget directly into the notebook. So a very powerful system that they've developed. Got a slightly more elaborate example of animation. This is a double pendulum, kind of a fun one. It's a two-dimensional ordinary differential equation. Since I'm low on time, I'm going to just skip over that, because I do want to talk a little bit about some of our challenges for the future. This is the double pendulum. It's a chaotic system, sensitive dependence to initial conditions. Okay. I'm sorry that I have to kind of move quickly here, but I'm basically out of time. I just want to point out Tony Yu, he's in the audience. This is how we used to do direction fields with quivers. You notice we have basically these straight arrows. Tony's added these streamline plots that are really nice. You have these basically direction fields where the width of the arrow you can control as a scalar. This is some examples of trying to make matplotlib graphics look like stuff I saw in the New York Times. This is an example of a cancer plot. Part of this was me saying, matplotlib has a standard look and feel, but it doesn't have to. We're really just a basic plotting library. So it's an example of showing how you can create different looks and feels. But I think we have some work to do to making it easier and making these kinds of graphics more intuitive to make. And that's one of the directions that's important. But the main thing I want to talk about that I think is the biggest challenge that we face going forward as a plotting library is client-side rendering. So we've gone a long way in matplotlib with our concept of the back end. We've had PDF and SVG and PNG and GTK, and that's worked well for us. But it turns out our backends are really stupid. The reason there are so many of them, they're really easy to write. They're just a hodgepodge of ticks and labels. They don't know anything about what an axis is or what a coordinate system is. So you can't pan and zoom on the output of a matplotlib figure. When you pan and zoom, we're generating new figures for you, basically. It's all server, if you want to think about it, it's all server-side rendering. But what's happened here with the IPython notebook is they've really broken up client and server-side rendering. Currently, we do everything server-side, which is why you're getting these static images inside these notebooks. But people need interactive client-side speed. They don't want to wait for their server to send down new data. And so we're really trying to think about, it's a new paradigm for us. The idea of the back end doesn't work. And I think I know what the solution is. It's essentially the concept of a pickle. We need to be able to take our top-level figure object and persist it as a very rich JSON data structure that we can pass over and allow client-side rendering. So if any of you are interested in working on that, we've got some ideas on how that should be done. Most people who approach it think it's a new backend. It's not going to be a new backend. That's not going to work. But there is a way to make it work, which is figure persistence as a JavaScript object. So I'd love to have some people working on that. I'd love to talk to more people about that. Thanks a lot. Captures that notion of the perception of the passage of time. I have a slightly different theory on that, which is the way you perceive time is directly proportionate to your age. So when you're 40, 5 years is 1/8 of your life. And when you're 60, 5 years is 1/12 of your life. And you perceive that as a fraction. So that kind of has implications that the older you get, the faster time progresses. So time has moved very quickly since our first talk, from my perspective, from my first talk at SciPy in 2004. So I'm going to kind of run over the seminal moments in matplotlib development and then move forward into some of the stuff that we've learned from there. We kind of had an ignominious birth in matplotlib. We were born out of rejection from my good friend, Fernando Perez. I was using Python since 2001. Formerly, I was a big Perl, MATLAB, and C++ user. And like a lot of people in those early days, I had a hodgepodge of work processes. I would have Perl scripts that called C++ numerical routines that would dump data files, and I would load them up into MATLAB to plot. After a while, I got tired of the talk about today. My title was, Lessons from Middle Age. And so I told my mom and a couple of my friends about my title, and they're like, well, middle age, what do you mean? Is that your project or is that you? And I was like, well, it's kind of both. There's some parallels between the age of a software project and the age of a person. When I started this thing, I only had one child and not a lot of dependencies, and I was kind of footloose and fancy-free and could do what I wanted. And now I've got a 14-year-old daughter and 2 other kids and hundreds and thousands of users worldwide. And there's just a lot more people depending on me, and it gives me a lot less flexibility to do what I want to do. And so there's some parallels there between age in a software project and age in a person. But I wanted to talk a little bit about the history of matplotlib. There was a NumPy thread recently where there was a lot of brouhaha and back and forth about NumPy community and development and process, and Travis Oliphant was mixed up in it. And one of the things I did in that thread was just want to say, to start off, thanks a lot to InThought for inviting me to come out here. And it's a big honor for me to be a keynote. I've been to many SciPy conferences and presented many times, but it was a big honor when I got an invitation from Prabhu and Warren to give a keynote here. And to the other sponsors as well, Microsoft and Google. I'm going to break my talk up into a few parts here today. Part of what I want to do is talk about the history of matplotlib and where we came from and why we did what we did, and where, moving up to where we are today. In the process of almost 10 years now of development of open source software, I've learned a lot of things. I have, taken on a lot of dogmatic views, and as I've gotten older, I've realized a lot of those dogmatic views aren't correct anymore. So I've learned some lessons, and I've learned some areas where those lessons aren't really true anymore. I want to kind of share some of those views with you that I've developed over time. One of the things I want to focus on is how to stay flexible as an open source software project. Kind of a history of NumPy versus numeric versus numarray, and Travis's role in bringing all those communities together. And one of my matplotlib developers emailed me off list, and he said, wow, I didn't really know there was anything before NumPy. And that was an interesting perspective to me, because NumPy came onto the scene in 2006, which is kind of late in the game for a lot of us. But for people who are grad students and college students who have been using these tools, that's sort of the whole history for them. So I thought it'd be interesting to give a little bit of history. My first SciPy talk was in 2004, which was 8 years ago. Again, in terms of the lessons from middle age, when you're a little kid and your birthday's 2 months away, you think, oh my God, that's an eternity. But then every time you see your great aunt, you haven't seen her for 2 years, and she says, oh my God, you've gotten so much bigger. And what's happening there is, to old people, 2 years is no time at all. But to a young person, 2 years is most of their life. So there's this great quote that I read that said, no matter how old you are, your first 20 years will be the best half of your life. And I think that case of technological change in the commercial world, in the open source software world, is really staggering. If you look at how fast leading technologies come and go. We've been around now for about 8 years, which is, it's an eternity in the software world. So how can we continue to develop and stay relevant to the new class of tools that are coming out? So I want to talk a little bit about how you stay flexible and how you stay young at heart as a software project. That'll sort of conclude the PowerPoint part of the talk, and then I want to move into more of an interactive demo showing you some of the new stuff we've been working on in the latest release of matplotlib, as well as the new stuff that's coming down the pike in our upcoming release in a couple months. A lot of good work from a lot of really amazing developers. And then the last thing I want to touch on is what I think are the big challenges we face going forward as a graphics library. And this kind of touches back on the idea of being flexible and staying young. There's a lot of sea change in the technology of graphics that's happening right now. And there's some particular challenges for matplotlib and how we can stay relevant in that world. So that's kind of the overview of what I want to